so to factor the top, what could we do?
We'll take 3x.
And that leaves us with?
Minus 1.
Okay. On the bottom, how would I factor that?
Easy method.
So x squared breaks into x. Multiply negative 12 and add to positive 1.
Minus negative 3 and 4.
Okay. Second thing are intercepts. An x-intercept is where you hit the x-axis. That's when our y is. This is an example though.
You bought? Makes sense.
So to find the x-intercept, that's when we make our y equals 0. Really, in a fraction, what part of that fraction has to equal 0?
The top.
The top. So you can set the whole thing equal to 0. It's a little bit faster if you just remember that's really just when the top of the fraction is 0. And we factored it for a reason. It makes this part much easier. So two things multiplied, one of them has to be a 0. What makes 3x equal 0?
0.
And x minus 1? Okay, and we're not finding these things just for fun. I expect them to be on your graph. So I would hit the x-axis at 0 and 1. Y-intercept? That's when we plug in a 0 for the x. So you can do the original, the factored, it doesn't matter. Every x becomes a 0. So 3 times 0 times negative 1 over negative 3 times 4. What's that turn into?
Negative 1 over, or negative 3, right?
0 over negative 12, which is just 0. So the y-intercept is 0. Okay. Now, we go into asymptotes. Vertical asymptote is x equals whatever makes the bottom 0. So what makes x minus 3 equal 0? And what about x plus 4?
Negative 4.
How do I draw those on my graph?
Up and down lines, dash lines.
Right. So I'm going to go ahead and plot those at positive 3.
Can you put them together like 3 and negative?
Sure.
Okay.
But I do want the x equals at least once. Okay. Next, horizontal or oblique. And how do we decide that? Degree. What's the degree of the top?
2.
Bottom?
2.
If it's the same degree, you divide the leading coefficients. So this is like a 3 over 1. Horizontal asymptote, y equals 3. Okay. Then what do we do?
Plug the thing into a calculator.
When you put it in, you have to remember parentheses around top and bottom.
Thank you.
so our graph should look like this. Keep in mind, we found all this stuff, so you need to make sure you're using it when you draw the graph. These asymptotes are lines that you're getting close to but not crossing. Okay, if you draw something like this, I'm going to count it wrong. If you draw something like this, I'm going to count it wrong. This is a curve getting closer to both of these lines as time goes on. The middle piece, we see kind of an upside down parabola. Now, does it just go flat in between those 2 points? No, that would mean every single one of those points is an x-intercept, and that's not true. What it's doing is going through the first, coming back down and hitting the second, and then approaching your asymptote. And then our final piece was also up here. Again, has to be getting close to both of these asymptotes. It's not on top of them, it's not crossing them, it's just getting closer. Okay? These are curves, so no sharp corners or anything. Any questions there? Let's look at one more. So first step is factoring. What do you have to do to factor the top?
Box.
Can we do the shortcut?
No.
So those multiply to positive 4, and they need to add to a negative 5. Okay, so then if we factor, so this would be a 2x, negative 1, x minus 2. X squared minus 4.
One, no, give me two squares.
So that's x plus 2, x minus 2. Okay.
Minus cancel.
Yes. When those cancel, we're left with 2x minus 1 over x plus 2. What is formed on our graph when something cancels?
The whole.
Okay, I want an ordered pair for that whole. We have to plot it on the graph. The x value, you look at what cancels. That was x minus 2. What makes x minus 2 equal 0? So that's your x. To find your y, you plug that 2 into what's left. So we get 4 minus 1 is 3 over 2 plus 2 is 4. So what that is at 2 3/4, you have an open circle on your graph. And from here on out, for my function, I'm just looking at this reduced one. Okay. X-intercept. That's when the top is 0. So that is at 1/2. Okay, how do we find the y-intercept?
Set x equals 0.
So if I plug in a 0 for all of my x's, we get
1/2.
negative
Okay.
1/2. Okay, next, asymptotes. Vertical asymptote is x equals whatever makes the bottom 0. What makes x plus 2 0?
-2.
That's a dashed line. Horizontal or oblique, you can look at the degree of the original or a reduced one, it's not going to matter. In the reduced one, the degree of the top is 1, bottom,
1.
if it's the same degree, that means it is horizontal,
By the coefficient.
so 2 over 1 is just 2. Alright, then what?
Plug in our original equation.
Yep. Your graph on your calculator is not going to show open circles, and that's okay. That's why we found them and we plotted everything. So if I plug in this, so we see this first piece again as you draw it, it's approaching, not crossing, not going on top of, just getting closer to those asymptotes. When you draw this piece, make sure you go through all your points. Don't accidentally fill in your open circle. Make sure it stays open,
What if we just like put a line through it, but like can you still see it's open?
as long as it's very obvious that it's open. Questions there? Alright, so that's the first one that we've actually graphed that had a hole on it.
So if there was like 2 that canceled out, there'd be 2 holes,
Yes.
and 3 there'd be 3 holes.
Mhm. Okay, what I want to do now is I have a handout